Hello everyone. Am I audible? Very good evening. Hello. Am I audible? Please let me know in the chat box. Please let me know if I'm audible. Very good evening to all of you. Okay then. Our topic for today is electrical networks, AC circuits. Correct? Yes. This electrical networks, AC circuits. Let us see the different MCQs. Of for this particular topic. Agdas Niaz. Good evening. Yes, everyone. So let us begin with the first question. So, in this question, they are asking pick up the incorrect statements of the following. The transient free conditions is possible for both AC and DC excitations. What do you think? Is it right or wrong? Yes, definitely it is right. See, they are asking transient free conditions. What do you mean by transient free condition? Transient free condition means steady state only. But we know that it is not possible. Why? Because for DC excitations, what are DC excitation? Whenever you have a DC voltage source, whenever you have some DC sources which are there in your circuit, and your circuit has things like LNC, inductor is there, a capacitor is there, kind of some things are there. Then in such a cases for DC excitation, it is not possible to have transient free conditions. Rather, you will be definitely having transient conditions. Is that correct? Is that right? Please let me know. So the P is definitely not correct. Then next, resonant frequency is unique for a given circuit. Yes, definitely resonant frequency is unique for a given circuit. What is resonant frequency? Under root of L by C, correct? 1 by under root of LC. Now, for the RC impedance function, the far most root is the pole. What is that? Is it correct? No. This is also wrong. This is also wrong. Next, the network with only resistances will act as attenuator. Is it right? Yes, definitely. Yes, you must have learned it in analog electronics kind of. Then the last one, the current magnification occurs in the series RLC circuit. Is it correct? Do you really think it happens? No, because it is which circuit? It is a series circuit, and we know in case of series, voltage is divided. Correct or not? Yes, which means definitely magnification will occur only and only for voltage in case of series circuit. So this is also not true. Now, what have they asked you in the question? What have they asked you in the question? They have asked you what are the incorrect statements. They're not asking you about the correct statements. Rather, they're asking you what are the incorrect statements. So this is incorrect. P, R, and T. They are incorrect statements. So you please tell me what is your option? What is your option? Your option is definitely option D. Is it right? P, R, and T. Any doubts in this question so far? Please let me know. Any doubts in this question? Any doubts in this question, guys? Please tell me. No, right? Okay. Then let us move on to the next one. What is that? The next question. And series and RLC series circuit has a resistance R of 20 ohms and a current which lags behind the applied voltage by 45 degrees. What are they having? An RLC series circuit. RLC series circuit they are given. Correct. It's kind of like this circuit. R, L, and C. Kind of. So this is RLC series circuit, correct? Yes. Now they are asking you, and a current which lags behind the applied voltage by 45 degrees with a resistance R of how much? 20 ohms. So they are asking 20 ohms resistance is there. Then they are saying that a current which lags behind the applied voltage by 45 degrees. Means, for example, if this is your applied voltage plus minus, let us consider V at an angle 0 degrees. Then they are saying it is lagging by 45 degrees. So current I is definitely at an angle of minus 45 degrees. Correct or not? Yes, honest. If the voltage across the inductor is twice the voltage across the capacitor, if the voltage across the inductor is twice the voltage across the capacitor, then what is the value of inductive reactance? They are asking. What is the value of inductive reactance? Correct. Let us see that now. What will be the voltage across this inductor? Let us assume that voltage across this inductor will be equal to plus minus VL, correct? Yes. Similarly, the voltage across capacitor to be, let us say, plus minus VC. Now, let us see what is I. What is the total current I which is flowing here? I at an angle minus 45 degrees, correct? What is this I equal to? I is equal to, sir, V upon how much? 20, which is resistance, plus what? J times XL minus XC, correct? Yes, sir, we know that. Now, the whole thing multiplied by, because we are using the whole thing multiplied by how much? 20 minus J into XL minus XC upon 20 minus J into XL minus XC, correct? Is it right? Are you all with me? Are you all with me? Correct? Yes. So this is equal to how much? If you simplify this, you will get 20 times V. Basically, what have you done here? Basically, what did you do here? You have done harmonic conjugate. See, harmonic conjugate concept, if you remember. So that what happens? See, this is A x plus Iy x minus Iy. If you multiply x plus Iy x minus Iy, denominator you will be getting square of this one plus square of this one. Correct or not? This is what we have learned in complex number mathematics, school level mathematics. Correct? Means see here, x plus Iy multiplied by x minus Iy gives you what? Nothing but x into x is x square. Now x into minus Iy, so minus Ixy. Iy into x is plus Ixy. Then plus Ixy, then plus Iy minus Iy is nothing but what? plus y squared, correct? So this is will get cancelled. Ultimately, you get x squared plus y squared. So the same logic you apply here, and you will be getting what? You will be getting 20 cos square, which is 400 plus xl minus xc. What is xl minus xc? Very good evening. Very good evening, Aziz. Yes, so this is 400 plus this is imaginary part. Imaginary part is xl minus xc, the whole square, correct? Yes, sir. Minus j times xl minus xc, because numerator also has to be taken care of, correct? Yes. So minus j times xl minus xc into v, the whole divided by the same one, 400 plus xl minus xc, the whole square. See, you multiplied this two because see, you did this, you multiply this v with this one, and then you get 20v minus j xl minus xc into v upon 400 plus this one, correct? Yes. Now, what is your angle theta? See, this is your real part. If you observe here now, see, this is your real part, and this is your imaginary part, correct? This is your imaginary part. Now you want what? You want angle theta. You want what is the angle theta? So it is what? Tan inverse of imaginary part upon real part, correct or not? Yes. Imaginary part upon real part. So it is equal to how much, sir? Tan inverse of. What is your imaginary part now? What is your imaginary part now? It is here, correct? Upon this. So kind of this and this will get cancelled at the end, correct? So you will be having here minus of xl minus xc upon 20v into v, correct? Yes, this is this one. No. What is it equal to? Vv will get cancelled, xl minus xc, and they have given this whole term to be equal to how much, sir? Minus 45 degrees, which is already given, correct? Yes, sir, minus 45 degrees. So now from here, what do you get? If this has to be minus 45 degrees, then this whole term should be equal to 1. So xl minus xc upon 20 should be equal to 1, correct or not? Yes. If I take 20 on the other side, I get xl minus xc. xl minus xc equal to 20, correct or not? Yes. Therefore, now, what have they given you? Is there some more information given? Sir, waiting for vector diagram in this verse. Which Phasor diagram, buddy? Are you talking about machines? Power system, which one? Which Phasor diagrams you want? Please let me know. I'll definitely try to sum that up here. Okay, anyways, now, what have they given? Yes, one more extra thing is given. If the voltage across inductor is twice the voltage across capacitor, means XL is equal to 2 times XC. Correct or not? If I substitute it here, what do you get? XL 2 times XC to 20, therefore XC equal to how much? XC equal to 20. Now, if XC is 20 and we know XL is how much? XL is 2 times XC. So 2 into XC. What is XC? 2 into 20, which is equal to 40. So your XC will become 40. Correct or not? Is it right? Any doubts so far in this? No, right? Okay, so this is done. Question number 2 is completed. Now, let us move on to the next question. In the circuit shown in the figure, I of t is a unit step current. The steady state value of V of t is. They are saying that I of t is a unit step current. The steady state value of V of t is. Let us see what is that. What is V of t here basically? What is V of t here? What we can apply here? See, it is steady circuit. It is steady state circuit, correct? Yes, sir. Steady state circuit. If it is steady state circuit, then what will happen? Unit step current is steady state value of V of steady state value. Steady state circuit. What happens? Inductor is short circuited. Capacitor is open circuited. So your net equivalent circuit will become like this. Like this. 1/2 ohms. 1/8 ohms. Short circuit inductor. That's it. And here you have got Vt plus minus V of t, correct? Yes, so I of t, correct. Now, what will you do? Let us find V of t. What is V of t? V of t is nothing but what? 1 into 1/10, which is equal to how much? Which is equal to 0.1, which is equal to how much? 0.1 volts. Getting my point? Yes or no? Is it very easy? Is it very easy? Correct? Now, next. Let us see the fourth question. In the circuit shown in the figure, output V naught of j omega is the talking magnitude is the same in j omega V naught of j omega. And options are indeterminable as value of RNC are not given. B is going to be 2.5 volts, C is going to be 5 root 2 volts, and this is 5 volts. Let us see what we can do. Okay. First of all, can you really see the values of RNC? Yes. No. No, correct? Definitely you cannot see them because they are not given. Just imagine if the values are not given and they are asking you to find the magnitude and there are some numbers given in the option, correct? Yes, sir, some numbers are there in the option. Now, but these values of R, see, will it be determinable? Because see, they are not given. So definitely the first question, though, definitely the first answer which will hit your brain is option A, because RNC values are as it is not given. So there is no point of having some finite value answer, correct? Yes, you are right, sir, but it is not true because we need to solve the question further and see whether what we are thinking is it right or wrong. If it is wrong, then definitely there will be some answer which will come, and that particular finite value will be nothing but one of the options from this given. Correct? Yes, okay. So what is V naught? V naught is equal to mod of VR minus VC. Correct? Yes. Therefore, what is VR? VR is equal to 10 into R upon 2R, which is equal to 5 volts. Correct or not? Yes. What is VC? VC is equal to 10 into 1 upon j omega c upon R plus 1 upon j omega c, which is equal to, if we simplify this thing, yes. Now, if you simplify this, what will you get? You will get 10 upon j omega cr plus 1, correct? Yes. Therefore, what is V naught? V naught is equal to 5 minus 10 upon j omega cr plus 1. Correct or not? Yes. Therefore, V naught is equal to how much? Come on. 5 j omega cr plus 5 minus 10, the whole divided by j omega rc plus 1, which is equal to how much? Come on. Plus 1, which is equal to how much? 5. If you take common, you will get j omega cr minus 1, the whole upon j omega cr plus 1, because you have taken 5 common. 5 minus n nothing but minus 5, and that will come in the picture. Now, therefore, if you further simplify this, you will get v naught equal to 5 into j omega cr minus 1 upon j omega cr plus 1. Correct? Correct? Yes. Therefore, what is v naught? V naught is equal to how much? 5 times. Because now, since you need magnitude, correct? You want magnitude. So, what is magnitude? Let us consider x plus iy. Magnitude is what? Under root of x squared plus y squared. Correct or not? Yes, sir. Under root of x squared plus y squared. Therefore, 5 into under root of 1 squared plus omega squared c squared r squared, the whole upon under root of 1 squared plus omega squared c squared r squared. Now 1 plus omega squared c squared r squared will get cancelled, and at the end you will be having what? 5 volts as the answer. Now the most beautiful part of this question is that there were no values given for r, and c. But still, the value that you got is a finite value, which is 5 volts. Hence, I was telling you that always cross verify with the answer. Always try to solve. Try to do something or the other with the question. You will, you will land up getting something. Okay. Yes. So this is 5 volts. So answer is option D. Correct. Your answer is what? Your answer is nothing but option D. Correct. Yes, sir. Now next, assertion A. When a sinusoidal voltage is switched, when a sinusoidal voltage is switched onto a circuit consisting of RLC elements, the response consists of two components expressed by free response and forced response. Reason: the response at t equal to 0 plus is called a free response as the voltage was just then switched, and when at t equal to very large is forced response, as it consists of value of RLC, applied voltage and its frequency. So they are asking you what is right. Both A and B, both A and R are true, and R is the correct explanation of A. Second one, both A and R are true, but R is not the correct explanation of A. A is true, R is false, A is false, R is true. Basically, this particular thing, if you must have studied AC circuits, you must have known. Statement A and statement R correct. Both are individually right. Individually, both are correct. I mean, this is also right, this is also right. But saying that this happened because of this is wrong. Getting my point? See here again. One more time, I'm repeating. This is right individually. This is right individually. But now, the moment you say that this is right because this is right, is wrong. This cannot be the reason for this. Cannot be the reason for this one. That is the reason. It is option B. Both A and R are right on their part, but R is not the correct explanation of B. Correct? Yes. Now next, let us see the next question. In the circuit shown below, if mod of I1 is equal to mod of I2 equal to 10 amperes, mod of I1 equal to mod of I2 means both the magnitudes of currents is 10 amperes, equivalent 10 amperes. I1 will lag by tan inverse of 8 by 6, I2 will lead by tan inverse of 8 by 6. I1 will lag by tan inverse of 6 by 8, I2 will lead by tan inverse of 6 by 8. I1 will lead by tan inverse of minus 8 by 6, and I2 will lag by tan inverse 8 by 6. I1 will lead by tan inverse 6 by 8. I2 will lead by tan inverse 6 by 8, correct? Yes, so this is the things given. Now, let us see what can be the right one. See here. There is a circuit given, correct? Yes. No. Anything else they have mentioned? Yes, I1 equal to I2 is equal to 10 amperes. Magnitude is 10 amperes they have given, correct? Now, the next one. So basically they have given you the values, correct? Now, let us focus on I2. I2 magnitude is given. How much is that? It is nothing but given to be 10. But what is that equal to? Yes, it is equal to IR, IR plus 8, correct? Because this is I2, correct? So here if you apply KCL, you will get IR plus 8. So IR plus 8. Now, therefore 10 is equal to this. From this, how much is IR? 10 is equal to under root of IR squared plus 64, which is equal to 6 ampere. So IR is equal to 6 amperes. Now next, input current at node B is I2. How much is I2 now? So I2 is 6 amperes plus J8. Therefore, I2 will be equal to how much? 10 at an angle of 10 at an angle of tan inverse of 8 by 6. Correct or not? Yes. So I2 will lead by tan inverse 8 by 6. No. Yes, sure. KCL. KCL at node A. What is that? I1 equal to IL plus 6 plus JB. So what happens at node A? Yes, here. This is let us say node A. This is let us say node B. What happens at node A? This is I1 equal to IL plus 6 plus J8. Correct? Yes. Now the only way I1 will become equal to I2 will be I1 equal to I2 का conjugate. Therefore, I1 equal to 6 minus 8. Therefore, I1 equal to 6 minus 8 is equal to 10 at an angle tan inverse of 8 by 6. Similarly, what about I2? I2 is equal to 6 plus J8, which is equal to 10 at an angle tan inverse of 8 by 6. Correct or not? Yes. So, current I will lag by tan inverse of 8 by 6. Correct? Yes. It will lag by tan inverse of 8 by 6. Now, what is question 7? Next one. For the circuits shown in the figure, the average power supplied by the source is. Now, what do you mean by average power? Average power is nothing but DC power supplied by the sources. So, let us see what is the mesh equation. See, this one definitely we can have mesh equation. Let me consider I1 current. Let me consider current as I2. Correct? What will be the first equation for I1? See, 2 plus 20 ohms. So now here you will get, if you apply KVL in loop 1, what do you get? You will get 2 plus J2, 2 plus J2 I1 minus 2 into I2, which is equal to 20. Correct. And second equation will be in loop 2. Loop 2, if you apply KVL, you get minus 2 I1 minus 2 minus J4 I2. Yes. So basically this is the equations. From these equations you get I1 minus I2 to be equal to 20 minus J2 into 5 minus 2 of 5 is equal to minus J10. How much is that equal to? Minus J10, correct? Yes. Now next. How much is the power source, power absorbed by 2 ohm resistor? 2 ohm resistor power they are asking, correct? So V square by R. The voltage across that resistor, or simply power is of a resistor, is going to be how much? 10 the whole square multiplied by 2. So it is equal to 100 into 2, 200 amperes. Now next, the transfer function of the series RLC circuit is VC of S upon V of S equal to H of S equal to 10 to the power 4 upon S square plus 100 S plus 10 to the power 4. The quality factor and the damping ratio respectively are, means they are asking you about Q, quality factor and zeta. Correct? Okay. What is H of S? What is H of S? 18, 10. So how much? 10 to the power 4 upon S squared plus 100 S. Now next, this is equal to how much K upon S squared plus zeta delta from. Yes. So what is the equation here? 10 to the power 4 upon S squared plus 2 into half into 100 S plus 100 cos square. This is the way. Now if you compare this with S squared plus 2 zeta omega n S plus omega n square, what do you get? What do you get? Definitely. If you compare, you get zeta omega n to be equal to 100. Similarly, your zeta is nothing but equal to 1 by 2. Omega n equal to 100. And this is what. But we know for the series RLC circuit, zeta is nothing but equal to what? 1 by 2 times q. So it is nothing but 1 by 2 times q. What is q? Q is 1 by 2. 1 by 4. So it is nothing but 24. Nice. The current in an AC circuit is given by 10 at an angle of 45 degrees ampere, and the voltage is 100 at an angle of 90 degrees. The current in an AC circuit is given by 10 at an angle 45 degrees, and the voltage is 100 volts. 100 volts at an angle 90 degrees volts. The active and reactive power in the circuit is. Yes. Now, if you observe here, what has happened? This question, what are they asking? The current in the AC circuit is given by 10 at an angle 45 degrees, and the voltage is 100 at an angle 90 degrees. Are the active and reactive? Yes. A and the ideal voltage is 100 at an angle 90 degrees. The active and reactive powers in the circuit respectively are. What is apparent power? What is other complex power? Complex power. What is P? V into I conjugate. What is that? 100 at an 90 degrees. Minus 10, which is equal to 10 at an angle minus 45 degrees. Therefore, you get 1000 1000 at an angle 800 rupees. And now it is this much. So, therefore, just see here is equal to how much? 1000 by root 2 plus j 1000 by root 2 if we take sinusoidal. This is the RMS voltage. So this is this way. So your answer is option A, correct? Yes. Now next. Consider the following statements related to resonance, and they are asking which is right. Which of the above statements are false? They are asking which are false. Okay, first one. In series RLC circuit, the admittance of resonance is maximum. Is it correct? Yes. Honest. In a series RLC circuit, the LC combinations and resonance is like an open conduit. In a parallel circuit, the angle between inductor and capacitor currents is 180 degrees, correct? Is it right? Is it right? No, just false. In a parallel circuit, the nature of the circuit is capacity for frequency less than 0. False. In a series RLC circuit, the current magnification will occur at resonance. Yes. So basically, you find Q, S, and T to be the false statements. If they're false, then definitely you can write down as Q, S, T as fault over here. Hindi. Correct? Yes. In a series RLC circuit excited by a voltage E equal to E sin omega t, where LC less than 1 by omega squared, then they are asking the current. Now next one. In a series RLC circuit, excited by voltage E equal to E sin of omega t, where LC is less than 1 over omega squared. Yes. What happens here? See, we have given LC is less than 1 by omega squared. So omega is less than 1 by omega. Correct? Yes. So at resonant frequency, inductive reactance is equal to capacitive reactance. We already know in magnitude. They cancel each other at a frequency less than resonant frequency. Capacitive reactance is larger and the current. Now next, a series circuit has an impedance. A series circuit has an impedance Z equal to 5 minus J12 as acceptance in. Correct? Yes. So now let us start. Yes. A series circuit has impedance of Z equal to 5 minus J12. Its acceptance is. What is acceptance? Y? Y equal to how much? 1 by Z, which is equal to how much? 1 by 5 minus J12. So 5 plus J12 by using complex conjugate, 5 plus 12 the whole square, which is equal to 5 by 169, which is equal to plus J12 by 169. Correct? Is it right? Yes. It was a very simple problem. Correct? Yes, sir. It was very simple question. Now let us see the next question. Just a minute. Yes. Now let us see the next question. The series RLC circuit is overdamped under. You are given list 1 and list 2, wherein you have to do match the following. Correct? Yes. Okay. So here first thing they have given, the series RLC circuit is overdamped when the unit of the real part of the complex frequency is. Second, the f of s is the Laplace transform of f of t. Then f of s and f of t are known as. Then, if f of t and its first derivative are Laplace transferable, then the initial value of f of t is given by. So these are the things. So list 1, list 2. What is list 2? List 2 given is how much? List 2 given is limit s t tends to 0 f of t is equal to limit as s tends to infinity s into f of s. Second is what? R squared by 4l squared less than 1 by lc. Third is radians per second. Fourth is inverse functions. Fifth is r squared under root r squared by 4l squared greater than 1 by lc. Sixth is what? Neper second inverse. And then limit as f tends to f of t, t tends to 0 is equal to limit as s tends to infinity s into f of s. So let us see what happens here. See. First thing, for series RLC circuit, for Series RLC circuit, what is there? For series RLC circuit, the first thing is your zeta damping ratio is equal to R by 2 under root of C by L, correct? Yes. Now, for overdamped system, what happens? What are overdamped systems? Overdamped system where zeta is greater than 1, correct or not? Yes. If zeta is greater than 1, we can say that this R of S, this RHS, that is R by 2 at an angle C by L is also greater than 1. Yes. Therefore, I can say that R squared by 4 into C by L is greater than 1, which implies R squared by 4L squared is greater than 1 by LC. Getting my point or not? Please tell me yes or no. Correct? Yes, sir. No. Question 4. In the circuit shown in the figure, if R0 is adjusted, what is the answer for this one? Or for this question? The answer for this question must be option A. Because A is 5. What is a series RLC overdamped system when? Correct? So now, in the circuit shown in the figure, if R0, Arshit Kumar, good evening. Arshit Kumar, good evening. Yes. In the circuit shown in the figure, if R0 is adjusted such that V mod of VAB is equal to mod of ABC, then theta equal to 2 times tan inverse of 2 into VBD upon V. V is mod of VBC equal to mod of VDC. C. Mod of VAB equal to mod of VAD. D. Theta equal to tan inverse of VBD by V. So these are the few questions. These are the few options they have given. So let us see which is right one. From this figure, from this figure, yes. From this figure, what do you observe? From this figure, what do you observe? From this figure, you understand that voltage across this VAD is same as voltage across VDC, correct or not? Yes. Well, exactly half, no? Exactly half because there are two resistances which are equal. So we can say that VAD is VAD equal to how much? VDC, correct? Because if you bring this A here, bring this C here, then you will observe that this and this they are half of each other. That's it. So this is it. Now therefore, magnitude of VAD is also equal to magnitude of VDC. Correct, sir. No problem. Given that, now they have already given you that VAB equal to VBC. What is their given? Given is VAB is equal to how much? VAB is equal to how much? How much is VAB here? VAB they have given it to be equal to mod of VAB is going to be equal to mod of VBC. Means both of magnitudes are given to be same. Correct? Therefore, Let us try to draw the triangle. Let us try to draw a phasor diagram. This is VAB. Let us say voltage. So let us call it AB. This is D point. This is C point. Correct. Angle. This is your I. Angle between this I and this VBC is nothing but theta. This angle is nothing but theta by 2, and that's it. So from this, what do we get? Of triangle ADB, and triangle CDB. You get AB equal to BC because already it is given, no? And AD equal to DC. Just now we find out mod of VAB equal to mod of VBC, and here since mod of VAD is equal to mod of VDC, correct? Yes. This angle of ADB equal to angle of CDB. That is 90 degrees, correct? Yes. Now, so triangle ADB and triangle CDB are which triangles? Congruent triangles. Which triangle they are? Congruent triangles. Therefore, we can say that angle ABD is equal to angle CBD, but angle ABC is equal to 180 degrees minus theta. Correct? Yes. Therefore, angle ABC is equal to 180 degrees minus theta divided by 2. This is equal to 90 degrees minus theta by 2. ABD. Therefore, angle of BAD equal to theta by 2. Now, in triangle ABD, what has happened? In triangle ABD, triangle ABD. So AB, I'll use another color. ABD, this triangle ABD, correct? In triangle ABD, you can see tan of theta by 2 is equal to mod of BBD upon mod of B by 2, which is equal to 2 times BBD upon mod of B. Or we can say that theta by 2 is equal to tan inverse of 2 times VBD upon mod of B, which is equal to 2 times tan inverse of 2 times VBD upon V. What is your answer? Answer is option A. Theta is equal to 2 times tan inverse of 2 times VBD upon V. Getting my point? Yes, sir. Very easy. Very easy. Correct? Now next. A series LCR circuit with R equal to 10 ohms, XL equal to 20 ohms, and XC equal to 20 ohms is connected across an AC supply of 200 volts RMS. Connected across an AC supply of 200 volts RMS. The RMS voltage across the capacitor is RMS voltage across the capacitor is there asking. So what is that? We know quality factor Q. What is that Q equal to? Mod of XL by R equal to mod of XC by R, quality factor. So we can get Q equal to how much? 20 by 10, which is equal to 2. Now, what is the RMS voltage across capacitor? We see RMS equal to QV at an angle minus 90 degrees. This is we know from the basics. This is equal to how much? Q is how much? 2 multiplied by 200 V at an angle minus 90 degrees. So it is equal to how much? 400 at an angle minus 90 degrees volts. Getting my point? Prima point, yes. So, which is the answer? Answer is option D. 400 at an angle minus 90 degrees volts. Correct. Now next, let us see question 6. Assertion A. A circuit containing reactances. A circuit containing reactances to be in resonance if the voltage across the circuit is in phase with the current through it. At resonance, the power factor of the circuit is 0. Both A and R are true. R is correct explanation of A. Both A and B are true, but R is not the correct explanation of A. A is true, but R is false. A is false, but R is true. Let us see. Right answer option. Let us see what it is. At resonance, what happens? At resonance. What happens at resonance if you know? At resonance, what happens is voltage across the circuit is in phase with the current. V and I are in phase, correct? Yes. And the power factor is 0. That is cos of 0 degrees, which means what is there? Is a circuit containing reactances shall be resonance if the voltage across the circuit in phase with the current through it? Yes. Reason that resonance power factor of the is 0. No, power factor should be 1. So answer is option C. Getting my point? Yes. Now next. The current I of t through a 10 ohm resistor in series with an inductance is given by current I of t through a 10 ohm resistor in series with inductance is given by I of t. Yes. It is given by a current I of t through a 10 ohm resistance in series with inductance is given by I of t equal to 3 plus 4 sine of 100 t plus 45 degrees plus 4 into sine of 300 t plus 60 degrees amperes. The RMS value of the current and the power dissipated in the circuit are A under root of 41 A ampere 410 watt respectively. Option B under root of 35 A 350 watt respectively. Option C 5 amperes 250 watt respectively, and option D 11 ampere 1210 watt respectively. Correct? No. So, what can you do with this question? Let us write down what is the given data. I of t, how much it is given? I of t is going to be 3 plus 4 sine 100 t plus 45 degrees, correct? Yes. Plus 4 into sine of 300T plus 60 degrees, this whole thing. Correct? They are asking RMS value. See here, different frequencies are separate on. Yes, hence to find RMS value, we have to use orthogonality property. So I of t equal to how much, sir? Under root of 3 cos squared plus 4 by under root of 2 cos squared plus 4 by under root of 2 cos squared is equal to how much? Under root of 3 cos squared is 9 plus 4 cos squared 16 over to 8 plus again 8. So this is nothing but 16 plus 9 under root of 25, which is equal to 5 amperes. Now, what is power dissipated to 10 ohm resistance? 10 ohm resistance power dissipated I squared into R. Therefore, I squared is how much? 5 cos squared into R, which is 25 into 10, which is nothing but 250 watt. So, answer is how much? 5 ampere to 50 watt respectively. So, it is option C. Is it very easy? Is it very easy? Yes. Now, next. For the circuit shown below, the steady state current I is what happens at steady state? Inductor will become short circuit, capacitor will become opposite. Correct or not? Yes. They are asking what the circuit shown the steady state current I is. How much is this? How much will be the current I through this one at steady state? Come on, how much will be there? I is nothing but what? Voltage at infinity upon 1 equal to 0 ampere. So answer is option A. Correct or not? Because at infinity, this voltage source, V at infinity, what is it? 5 into under root of 2 e to the power minus 5t. At t tending to infinity, what will happen? 5 into under root of 2 into 0. Because e raised to minus infinity is equal to 0. E raised to infinity is infinity. So, in this case, your answer is going to be 0 ampere. Are you getting my point? Yes, sir, 0 ampere. Yes. Now, next. The power factor of the circuit. The power factor of the circuit shown in the figure is, what is the power factor of the circuit shown in the, let us say that what is this? 5 equal to under root of IR squared plus 4 squared. Correct or not? Yes. Which is equal to how much? Therefore, 25. If you square on both sides, you get 25 equal to IR squared plus 16. Therefore, 9. 16 goes there, it becomes 25 minus 16. 25 minus 16 is 9. 9 equal to IR squared. Therefore, how much is your IR? How much is your IR? IR is nothing but root of 9, which is equal to 3 amperes. What is your cos phi? Resistance upon I total. What is resistance? May say current. It is 3 ampere. Upon total current is how much? Phi. So it is 0.6 lead. That's it. Problem solved. So it is 0.6 lead. Option D is the answer. Correct? Yes or no? Now next. A two-terminal network connected consists of two terminal network consists of one of the RLC elements. The element is connected to an AC supply. The current through the element is I amperes. When an inductor is inserted in series between the source and the element, the current through the element becomes 2I amperes. What is the element? What is this element? See, V is equal to what? XL minus XC into Y, correct? And they have given XL equal to 3 times XC. So, XL is 3 times XC, so this becomes 3 times XC minus XC into Y, which is equal to 2XC into Y, that is V. Correct or not? Yes. Then the element cannot be inductor. Why? Because otherwise the current will reduce. Yes or no? Yes. Otherwise the current will reduce, but it is increasing. That is the reason your answer is option C, which is the capacitor. Correct or no? Yes. So this was the whole story behind the session. I hope you have enjoyed these beautiful questions. Let us meet afterwards as well. Well, let us meet next week probably. Let's see whenever we'll be having some class. Okay. Till then, chalo, tata, bye bye. Good night, everyone.